Few realized that even during the Korean War, seemingly small details in construction could have outsized consequences. Military engineers frequently faced the challenge of erecting field structures, supply depots, and temporary bridges with locally sourced timber. One subtle but critical issue was how nails were driven into wood. Misplaced nails caused planks to split, beams to weaken, and temporary fortifications to fail under weight or stress. Soldiers and engineers learned quickly that the placement, angle, and spacing of nails mattered as much as the timber itself. This was not a matter of aesthetic choice. It was the difference between structural integrity and collapse, a lesson that builders had understood for centuries before mechanized construction. Examining why nails were placed differently in older timberwork reveals a depth of knowledge about wood, human craftsmanship, and practical engineering that, honestly, modern builders often overlook. Understanding this history allows us to see how meticulous attention to material behavior has always been a matter of survival, whether in civilian carpentry, military engineering, or survivalist construction. Old builders actually treated nails as part of the material itself, not just as some separate tool. In traditional timberwork, nails were not simply hammered in wherever convenient. Craftsmen really thought of nails as extensions of the wood itself. They understood that wood is a living material that expands, contracts, and twists with changes in humidity and temperature. Placing a nail without considering the grain direction or the wood's natural movement could, easily cause splitting or even warping. Builders, they really learned to read the timber, paying close attention to whether the grain was straight, quarter-sawn, or flat-sawn. They would then adjust nail placement accordingly, which honestly made all the difference. During the Korean War, engineers, they had to make similar decisions right there in the field. They quickly discovered that the standard rules for nailing, straight, evenly spaced, perpendicular, were just not enough for timber that had been freshly cut, air-dried, or locally milled. Those who adapted nail placement to the timber's character, they were the ones who constructed structures that endured harsh winters, heavy snow, and the stress of repeated use. Misjudgment, even by just a few inches, often resulted in weakened floors, compromised walls, or, twisted planks. The lesson is clear. Nails are really effective only when they work in harmony with the material they bind. One of the most critical aspects of traditional nailing was, honestly, accounting for grain direction. Old carpenters knew that nailing across the grain increased the risk of splitting, while nailing along the grain allowed the wood to absorb stress, which is pretty clever, actually. In hand-framed timber buildings, nails were often driven at slight angles, rather than straight in, a technique known as toe nailing. This method allowed the fastener to anchor multiple boards together while minimizing the chance of splitting or weakening the wood. Field engineers in Korea learned the same principle under pressure. Timber planks used for floors or roofs were carefully oriented, and nails were driven at angles that complemented the grain. In many cases, vertical posts were toe-nailed to beams rather than nailed straight through, creating a structure that remained stable under load despite the natural movement of the wood. Engineers observed that structures built without this consideration often developed warping or gaps within just a few weeks, demonstrating, really, that the lessons of historical craftsmanship were as relevant as ever. Traditional builders also understood that spacing mattered. Driving nails too closely could create stress points, causing splitting or weakening the timber. But, if they were placed too far apart, the connections simply would not resist lateral forces. Experienced carpenters, they relied on rules of thumb, always adjusting for things like timber species thickness and, moisture content. Oak, being dense and slow-grown, could actually tolerate closer spacing, whereas pine needed wider intervals to prevent splitting. During wartime construction, these spacing decisions honestly had some very practical consequences. Bridges, observation towers, and temporary shelters often depended on fastened timber for their main support. Engineers who ignored spacing principles more often than not found planks loosening under weight, which meant repeated repairs. But those who applied historical methods, calculating intervals based on wood type and expected stress, they produced structures that endured repeated use without failure. Old carpenters were, really meticulous about selecting nail length and type. They knew that short nails could pull out under load, while excessively long nails could split the wood or, even protrude on the opposite side. Smooth-shanked nails allowed for a bit of movement, while ring-shanked or square nails offered extra grip where necessary. In hand-framed buildings, nail choice was actually part of the overall structural calculation, coordinated with joint type, wood species, and the anticipated forces at play. Military builders in Korea faced, the same challenge. Supplies of nails were limited, and local timber varied quite a bit in both density and thickness. Selecting the correct nail, often having to improvise with whatever locally available iron spikes they could find, was absolutely critical. Field manuals of the time, interestingly enough, even referenced different nail types for pine versus oak, or for soft versus hardwood. Engineers learned to adapt on the fly, applying centuries of practical knowledge to a wartime environment. Traditional joinery demonstrated the most careful approach to nailing. Builders rarely drove nails directly into the end grain of a beam, knowing that it was prone to splitting. Instead, they secured boards at midpoints or, just slightly offset from joints, which allowed the wood to move without actually weakening the connection. In mortise and tenon or lap joints, nails were often used sparingly, mostly to, hold the structure during assembly, while pegs or wedges provided that long-term stability. Korean War engineers, interestingly enough, applied similar strategies. Temporary shelters had to withstand winter freezes, rain, and shifting soil. Nails placed incorrectly in end grain led to planks pulling apart or posts loosening. Those who positioned nails with an understanding of grain orientation and long-term wood movement created structures that survived multiple seasons, often outlasting hastily built alternatives. Above all, historical nailing practices reflected a deep respect for wood as a material. Builders approached each timber individually, adjusting angle, spacing, and type of nail based on the characteristics of the wood. This attention to detail ensured longevity, structural integrity, and adaptability to environmental stresses. It was a system built on observation, experience, and patience rather than brute force. The connection to military engineering is striking. Soldiers in Korea, pressed for speed and dealing with variable timber quality, found that respecting the material, placing nails thoughtfully, accommodating movement, produced reliable results. These lessons underscore that traditional techniques are not simply quaint relics of craftsmanship. They are, in fact, applied science. Understanding why nails were placed differently in historical timber work offers more than just a glimpse into carpentry. It teaches principles of material behavior, adaptive engineering, and risk mitigation. Whether constructing field structures, emergency shelters, or sustainable timber buildings today, the underlying logic holds: anticipate movement, distribute stress, and respect the natural properties of materials. For survivalists or builders working with minimal tools, these principles are invaluable. Proper nail placement reduces failures, extends the lifespan of structures, and minimizes the need for repairs. It's a form of knowledge that, well, truly transcends eras, showing us that what might look like a minor technical detail, such as where and how a nail is driven, can actually carry some pretty profound practical consequences. The story of nails in old timber work is honestly a story of observation, adaptation, and a deep respect for materials. From centuries-old barns to, Korean War field structures, the careful placement of nails ensured both durability and stability. Ignoring these lessons really does risk repeating historical mistakes, things like splitting wood, weakened connections, and, honestly, structures that just fail under stress. By studying the practices of past builders, we gain not only technical insight, but also, a mindset that values precision, patience, and a real understanding of natural forces. If you value uncovering the overlooked aspects of history that shape practical outcomes, go ahead and subscribe to History Matters. Share this video with others who, appreciate the depth and nuance of historical craftsmanship. Remembering why nails were placed differently in old timber work is more than curiosity. It is honestly a window into human ingenuity, survival, and the lessons we can still apply today.